try to
This
get at the
conference
end
will
of the
now be recorded.
okay. If you enter questions in the chat, I'll try to get them at the end if you want to do it that way. Or you can just speak up. There aren't that many people on the phone here, so we can probably manage it that way. So I guess Sam gave you my introduction, and so I'll just start right into. We're talking about Ashrae 90.2 2018, and high performance residential buildings, because 90.2 2018 transformed standard 90.2 from a base code level standard to an above code level standard in terms of being more of a leadership standard. So I'm going to go through basically the background along that and why we need it. And I am sorry I couldn't join you in person. I think you all know there were Omicron sort of hit. We were planning on doing this in person, and then Omicron hit. But just to let you know who I am, this is from my first, and that I've been to Alaska. I was on the Cold Climate Housing Research Council Board of Directors for a while, and this is my first visit in October 2014 to Homer, Alaska, with my husband when I attended a board meeting there. So just to let you know, I didn't not come because of the cold. I didn't not come because I don't like Alaska. I actually think Alaska is a beautiful, beautiful state. But traveling with COVID, well, actually probably would be better now than when we decided to go virtual, but that's where we are. So with that started, just to start with a couple of base slides. This is part of the Distinguished Lecturer Program. This is my first year being a Distinguished Lecturer. You guys are probably all on mute from background noise rather than silencing your phone. The evaluation forms are important, especially as a first-time Distinguished Lecturer. So I imagine your chairman or program chair will be able to give you this. And the lecture presentations and opinions do not necessarily the policies or position of Ashrae. So although I'm talking about 90.2, and I was chair of SSPC 90.2 for multiple years during the development of the 2018 version of the standard, this presentation reflects my own opinions, not Ashrae's. And then there's more information of the DL program available. Okay, so also it looks like you have a very active chapter, but Ashrae is always looking for leadership. So join and be a part of technical committees, standard committees. It looks like you have active YAY members, and your chapter is very active, so I don't necessarily need to say the end, but just trying to make sure we do all. I think we all love working with Ashrae, and hopefully we'll get back to being more in person as this year goes on and we finish with this COVID stuff. So what I'm going to talk to you about today, I'm going to do a little bit of introduction in building energy codes and the needs for them and how 90.2 fits into the needs for them, and then talk about how we did the transformation of 90.2 and the process that we went through as we transformed that standard, and then go through what is in 90.2, how it works, and then the work since the 2018, the approved addenda, and a proposed addenda that's out now, and what we're doing in terms of coordinating with IECC with 90.2. So building energy codes are really all about sustainability and trying to help with the climate change issues that are coming down the line. That mean melting glaciers, wildfires, storms, and floods. And I'm sure you in Alaska have had your share of all of these things. that's ultimately what building energy standards and codes and improving them mean to our world. And if you look at what National Resources Defense's funds say, they show that energy efficiency is a huge part of getting to the emissions reduction that will help stave off some of climate change. And when you look at the U.S. Consumption by sector, residential is just under a quarter of the energy consumption. This is as measured in 2020. So 90.2 is the residential code, or standard, and that's the pie that we're looking at. And you can see it is very important to the overall greenhouse gas and climate change initiatives that our country and actually the globe is working with. If you look at our energy code, and the yellow is the residential code here, you'll see, and I want to show the timeline because it shows the world in which we developed 90.2 in, because you'll see took quite a while to get to the 2018 code. So we did, so the yellow curves here are the energy code. I don't know if you can see my pointer, and you can see that it gets more efficient in fits and starts. It'll go for multiple years as a plateau, and then it'll drop a little bit, and then it'll drop some, and then it goes straight for a while, and then it'll drop, and then it'll go straight. We had our last, actually, the 2021 code had the DOE evaluation of that code shows a 9.38% savings over the previous code. So when we went from 2018 to 2021, we had another drop. So we are getting more efficient over time, but it's not clear that the rate at which the base energy code is becoming more efficient over time is going to lead us to get where we need to be. And IECC basically put together this Leading the Way for Energy Efficiency document in the last year, and they talk about the intent of the code. And so we have a energy efficiency minimum code, and then additionally, they want to, in their codes, provide jurisdictions with additional requirements so that they can lead to zero energy buildings by 2030. And it's not clear that the base will get us all the way there, or the base code will get us all the way there. So we're looking at above code standards, more energy efficient programs to do that. And so we're putting together a toolbox, and 90.2 is part of that toolbox going forward. So that just gives you a little idea of where 90.2 sits in the overall basis of energy codes and standards. So what was the pathway by which we got 90.2 delivered? And so 90.2 has been around for a long time, but it was basically, the last version that was published was 2007, and it was not used very often, which is a charitable way of describing it. And it was sort of Me Too didn't really provide any leadership or above code incentives for the industry. So we went on this pathway to develop, and the pathway was really we did some work in the initial, but the pathway was really defined by a standards advisory panel that was it was an ad hoc panel that was assembled by Tech Council at Ashrae, and we met for quite some time and came out with some recommendations. And the base goals in here and recommendations are written here, and what they talk about is 90.2 being positioned above the base code. They said having something that would simply echo the IEC's minimum standards didn't really make sense for an Ashrae. It was of questionable value to the industry and to Ashrae to do that. They didn't want to go all the way to a green code, which would include things other than the broader aspects of sustainability, other than energy efficiency. So they wanted 90.2 to become a high performance residential energy code, but not necessarily a building code. And so that was what they looked at for as a leadership energy standard. And that was the overall goal that we were working with. And then there were 11 specific recommendations in terms of what the resulting standard would look like. There were some other recommendations in terms of how we should work, but these are the base recommendations that we wanted it to be an international a standard that could be used internationally, or these were their recommendations. Standard that could be used internationally, that was on the path to near zero energy or net zero energy by 2030, and that the first revision would be a 50% improvement on the 2006 IECC baseline. And that seems a long time ago as a baseline, but it took a while to get this. So that was 5 years before this recommendation came out, and then we took another 6 years to get the standard fully out. Addressing the energy aspects related to indoor environmental quality, including comfort, moisture control, and indoor air quality. This was not to actually do the standard writing around comfort, moisture control, or indoor air quality, but to address energy aspects that potentially would be related to those. Do not address the broad subjects of sustainability, so not to be a 189 type of standard. Consider the energy aspects of meeting residential water needs, incorporate cost effectiveness as a significant criterion. So even though it was above code, we still wanted to include cost effective ways of managing this, incorporate appropriate field performance metrics to measure compliance. Basically, we need to have some verification in there, easy to use and easy to enforce, which of course is always in the mind of the beholder. Evaluate an alternative compliance to look at whether or not energy use intensity was a good energy criteria. We decided that we did look at it. We decided as a committee that that was not the direction we were going to go actually after this recommendation came out. Evaluate the inclusion of plug and process loads and evaluate the use of renewable energy alternatives. So those are the recommendations that we came in with. And what we ended up producing was the 90.2 2018. And I'm going to go through what's in this what we call the leadership standard, and then at the end I'll just review how it met those recommendations or how we pursued those recommendations in terms of where we're going with this. And the main goals is that we wanted a leadership standard, we wanted it to be flexible, and we did want to have cost effectiveness involved in the criterion setting. So what the standard looks like, this is basically the design of the standard in terms of the contents of it. And it's set out like and I'll go through this again, there's a couple of things in there. It's got the basic requirements, it's got some appendices that are normative, some appendices that are informative, actually quite a lot of informative appendices that help with the implementation of the standard, including things like an informative example site inspection checklist, etc. So if we look at the purpose of the standard didn't really change. It's still, the word minimum here, it's still written as you can meet this or exceed it. So it's still written as a minimum performance requirement, but it's not necessarily the code minimum. It's just the standard gives you have to do this level or better in the way that it's written. And one of the biggest changes is that manufactured housing was no longer exempted. In 2017, manufactured housing was exempted from 90.2, and it's no longer exempted in this. In fact, we are, as a committee, actively pursuing the specifics of how manufactured housing can benefit from 90.2 as a stretch code for manufactured housing, and there's some efforts going on in that area right now. So as we look at again back at the definition outside of the scope, or at the table of contents, you notice there's performance requirements. There's some additional specific sort of prescriptive baseline requirements, but it's mainly a performance standard, and it's performance standard based on an energy rating index. And then the way we put flexibility into this standard was to put into the appendix a procedure for generating prescriptive paths based on these performance requirements, and then an example of one with NACA minimums for the mechanical equipment in there. And so the idea, and I think this is really important for an area like Alaska where you may have different criteria that you want to use. So instead of having performance criteria, prescriptive criteria, you can use the procedures and the performance requirements to actually generate a prescriptive path that meets the regional concerns of your area, the climate. I mean, things are designed in climate zones anyway, but the type of building that you do, and also if there's a particular method of construction, you can actually define a prescription path that is sensitive to that particular method of construction. So we felt that it made it prescriptive, it made it very flexible, because you could actually develop the prescriptive path that fit the situation you were in the most. And that is how we dealt with trying to be flexible. And I can tell you, as somebody who dealt with, in my day job, product development for a number of years, having the ability to say, this is how it fits in, and I can develop my a prescriptive path that involves, say, a new product or a new system or a new method of building. That I viewed that as a very positive advance in the standard. So the residential performance did end up being 50% more energy efficiency than the 2006 IECC. The performance is based on the ResNet energy rating index. As originally raised, it was on 2014 with Addenda A and Addenda E modifying it. This is when it came out in 2018. It has since been updated to the more recent version of 301 through an addenda. I'll mention that later. But when it first came out in 2018, this is what the performance was based on, and it was based on an energy rating index. Energy rating indexes, I'm pretty sure you know, are similar to a HERS index. They're slightly different. In the HERS index, so the performance is based on that. We do have some exceptions added into the rule set that is used in ResNet 301. Actually, some of the addenda that are mentioned here came out of developments that we did in 90.2, and then they were added as addenda into ResNet 301, so we just adopted the addenda. But we do have some changes to the rule set, the majority of which are in the lighting section. But it is basically an ERI type scoring performance criteria. And this is how the ERI indexes compare to what is in the code. So these are the numbers. These are the maximum ERI score to meet 90.2 2018. And you can see they're significantly lower than the 2015. The 2018 actually went up from 2015 in the ERI pathway. 2021 went sort of back to the 2015 levels. So we're still significantly lower. And then there's an appendix in the 2021 that goes towards net zero energy, and there are some complications on using it because these are the numbers without solar being used, but you can see that they are the same numbers that are in 90.2, and then you use solar to get it down to net zero, to go to net zero. So, or renewables, not just solar. And so you can see that that the 90.2 ERI rating is basically the type of rating that we are using to bridge that gap between a code minimum and a net zero energy building. So some of the additional requirements that are on top of this ERI. These were things that we felt needed to be done in addition, just to help get the ERI, to get you to the ERI and give some minimum backstops to make sure it's getting there in the best way possible. So these are more backstops and baselines than anything else. But for the building envelope, we do have a backstop on air leakage and building thermal envelope insulation levels. And then there's a mandatory verification of insulation installation and verified air leakage. And you can see there's a number of additional standards referenced, mainly to do with air leakage testing. And the installation requirements are in a normative appendix. So these are required, and they are around verification to make sure that the building envelope is built as you design it. For mechanical systems, there's proper sizing and verification of the duct system performance required. There is a requirement for all ducts to be within conditioned space, but they do have an allowance for buried ducts. And there's a requirement to HVAC design and requirements for design, installation, commissioning, and verification. These are mainly through the various ACA manuals, and you can see once again the list of required various referenced standards or manuals in terms of quality installation verification as well as design for the mechanical systems. In addition to the HVAC mechanical systems, plumbing system design and installation levels and controls are required. So you want to minimize pipe length for the water heater to discharge points, and verify that the water heating systems actually match what's in the proposed design. So again, verification, some additional requirements that did not fit cleanly into the ERI criteria. For indoor environmental quality, there was we didn't want to actually put requirements in there that weren't in elsewhere, but we wanted to make sure that the buildings would have a good level of indoor environmental quality. So we referenced Standard 55, Standard 62.2, and Standard 62.1 for common spaces and multifamily, and then also have the illumination quality, which we are actually working on to make clearer in the upcoming addenda. And so that gets us into lighting systems. And the lighting systems, we have revised modeling rules for quantifying residential lighting energy. And this was the biggest change from the ResNet 301 rule set with some revised modeling rules on lighting. There are credits for the use of vacancy sensors, dimmers, and other control devices, and some revised lighting allowances for interior, exterior, garage, and other residential lighting. So it's quite comprehensive as a standard. Also, one of the things we wanted to do, we allow on-site power production to meet the ERI requirements. That is, if it's not being used in that IECC addenda, that was addition. But within the standard, you can use on-site power to meet the ERI requirements, but there are building thermal envelope insulation and air leakage backstops to make sure that you are looking at making the building efficient first and then adding the solar on afterwards, because that is the best way in terms of the longevity of the energy efficiency and really getting the energy efficiency down for the product. So if we look at,
I got a question.
yeah.
In Fairbanks, there are 3 months out of the year that solar tracking solar units can't power their tracking motors.
Mm-hmm.
So how would somebody in Fairbanks meet this these site power requirements?
See, you wouldn't, you might not use them. I mean, so you're not required to have site power.
I see.
You basically, you can use them to meet your ERI score, but you don't have to. So what you could do is meet the ERI score without the solar power, and then put the solar power on to get more efficiency during the periods of time when you could use them. Because I recognize Fairbanks is an issue, and North, for instance, North would be
right.
quite an issue. So so we did not want to require on-site, but there are some, because this is an international, we wanted it to be able to be used internationally and certainly all the way across the U.S. We wanted to recognize that if you've got the capability of using it, you can use it to meet this ERI score.
Okay, thanks.
Does that make sense?
Mm-hmm.
Okay, so these are the panel recommendations, and pretty much the requirements of all of these recommendations we addressed at least partially. I don't think we went 100% on all of them, but we certainly got to like an 80-20 rule on those. But I wanted to talk a little bit about the two that I've highlighted here: the cost effectiveness calculations and evaluation, and also the ease of use and easy to enforce, because that's a real somewhat vague recommendation. Like, how do you evaluate that? So cost effectiveness, what we did to establish cost effectiveness while maximizing the energy efficiency was we used a life cycle cost analysis, and we used specific adopted economic parameters. In fact, we, as a committee, it took us quite a while to get these economic parameters set, and they are quite conservative. Adopted national average energy prices. Those energy prices may have changed, so we may want to redo this cost effectiveness or do it regionally, but that was how we got there initially. We did use the DOE Building America Source Energy Multipliers and looked at a 30-year life cycle cost, and you can see the method that was used was a whole home LCC analysis, including lighting, appliances, and miscellaneous energy use. So there was some schedules put in there on miscellaneous energy use and appliances, and they targeted a savings to investment ratio of between 1 to 1.1. So what does that mean? Well, you're going to get a curve and you're going to start getting cost savings, percent cost savings on life cycle costs going down as you go up in energy savings, and then the life cycle costs will start going on. We did not target the minimum energy cost savings. What we said was we wanted it to be in the 1.1 to 1 range. So we are at the most energy savings you can get without increasing the life cycle cost as opposed to the minimum total. So it was maximizing energy cost savings while being cost effective. And that was the philosophy behind the cost effectiveness study that we did. And there were 2 evaluations looked at. One was an NACA minimum. This did have on-site power production, and then an alternative without on-site power production to see if we could look at cost effectiveness under those 2 somewhat divergent scenarios. And you can see where we have, and we were targeting 50% over the reference design. And these are the climate zones that we did these in. And you can see with PV and with no PV, and then what the recommendation was for the value that we got. So with PV and without PV, the energy rating index may have been quite a bit different, but we picked the middle one as the recommended compliance ERIs. And we did this with a number of scenarios. But it was basically to determine that we wanted that these were achievable numbers, not necessarily going to give you the minimum cost, life cycle cost for everything, but they were achievable in the cost effectiveness range. Then when we move to the idea of easy to enforce, you look at, well, what does easy to enforce mean? Well, one thing you can look at is what's happening with code officials. And basically a lot of them are retiring and leaving the business, and a lot of more are going to over the next 10 years. And this is from a demographic survey from 2014, but so so the ease to enforce, you wanted to do it, to have enforcement able to be in a way there where you were already compensating for, say, the loss of some of the code inspectors. And so that is one of the benefits of having it an ERI-based code, is because there's already an IECC HERS compliance specialist designation. So there's already the idea of ERI is already an existing pathway in the code. You've got these third parties that are qualified, already have a qualification designation within IECC. HERS raters are known. This is a similar type of system. So it makes it a lot easier to enforce. Having clear validation requirements that are verification requirements that are referenced to standards also makes it easy to enforce. So we basically said that was how we were going to make it easy to enforce. We weren't starting up with a totally new system. We were working off what was within the industry at the moment. And so in conclusion, we met the standards advisory panel recommendations, not all of them 100%, but we went there at least partially with any of them, and I can answer more questions about those when we finish. But we felt really good that we were able to include so many of the recommendations in the rewrite. It took a long time to do it, not without a lot of discussion and in some cases maybe controversy while we were doing it, but we moved forward and did meet those recommendations, or stepped up to the plate on them. So what did we do since the publication, which was in December of 2018? So when we say 2018, we went right to the end of the year in 2018. what's on the horizon and what have we done since then. One of the things that we've done this year, and it's still going through it hasn't been evaluated by the committees yet, is we proposed, because the numbers were already in the 2021 code, we proposed for this net zero residential energy appendix in the IECC, replacing just using the ERI numbers with using 90.2, because 90.2 provides a lot more information on how to do it, how to get verification, and we left in a lot of the things around how you validate the renewable energy sources, but basically took it from just a table to saying we're proposing that Ashrae 90.2 2018 will make this appendix actually more doable for the jurisdictions that decide to adopt it. So we'll see whether or not the consensus committee agrees with us, but we are putting it forward as basically the stretch code part of that glide path, consistent with what I showed in the beginning of IECC looking to have these appendices which help individual jurisdictions. We've also moved forward on improving the standard. This is sort of maintenance. We've updated the references. Because we were somewhat new coming on the scene, we were a little out of sync with some of the references, so we're trying to get that in sync well with revisions to the references, updated them, added some new testing. We did do a clarification of lighting provisions, applications to common areas versus dwelling units in multifamily, and where you use what criteria. And then we have an addendum that's out for public review until March 21st. So if you have a comment on this, please give us a comment on this. And there's some very important things in this, because we are looking at expanding the title or revising the title consistent with an expansion in purpose and scope of the standard. And the first thing is we are currently, it's low-rise residential buildings, and we are looking at expanding this to all residential buildings, because you can basically evaluate by a combination of dwelling unit and common space, and so that gives some ability to maintain, to use the same standard over all residential occupancies or multifamily as well as single family. This is similar to changes that we've seen coming through in 62.2, and there's a real what happens is multifamily sort of falls through cracks between commercial code provisions and residential single family code provisions, and this is an attempt to bridge that gap. We are also looking at not just a low energy consumption, but also looking at carbon and low greenhouse gas emissions, adding that to the standard. And ResNet has started looking at doing carbon as part of an evaluation index, a separate index within ResNet 301, and so we are looking at that. We think that carbon is where one of the criteria that need to be are going to need to be followed, and if you want to stay in a leadership position as a standard, you need to actually step up to the plate on that. How we do that exactly is we're still working on. So these are sort of this title, purpose, and scope is to some extent aspirational and some a work in progress, but I would, if you want to comment on it, we really would like comments on the title, purpose, and scope change. You can see the scope change Most of this has to do with moving from just low-rise residential to multifamily, but we also are looking at covering some connected controls, so connected thermostats and controls, as well as others. The rest of it is some wordsmithing for clarity in there. We already covered the use of renewable energy systems, maybe not the energy systems themselves in detail. So that's there. So 90.2, we attempted to answer what was a leadership code with the criteria that was in there. And it was something that's on a pathway to net zero energy buildings, including aspects of these areas that aren't just the HVAC and building envelope a part of it, and lighting, the traditional, but try to look at some of the other energy use aspects of it, and to address implementation, the validation, the ease of adoption, and the benefit of the cost. And that's what we are trying to do as 90.2. We hope we produced it as a committee, and I think it's a fairly good product. And I'd from a personal standpoint, I'd like to see it considered more in different regions and states going forward, and to take a look at it. So I will finish there and go to questions, but I just want to acknowledge SSPC 90.2. I was chair for about 6 years, and I worked with some amazing people. And the past and current chairs of 90.2, the two chairs before me, Merle McBride and Philip Ferry, and the current chair is David Goldstein. And Philip and I are still members of the committee. There's a commitment to 90.2 moving forward. And I'd also like to acknowledge the Ashrae Residential Building Committee, who worked with me on becoming a distinguished lecturer and presenting on 90.2. So, and finally, I'll thank you for your attendance and go with any questions. And I made it under the hour, which is amazing for me. I usually talk a lot. So I will finish there. If there's any questions, I will open the chat if I can.
Hi, Teresa. This is Phil Hayes. I got a question just to throw out there. So my understanding is the current energy score does not take carbon into consideration. For instance, adding solar panels. Okay, so if you were coal-driven power, you might get more for solar panels versus on a renewable grid.
Yeah. So, and we just had a meeting like 3 hours ago where we were discussing the carbon issue in 90.2, and so it's very much something that's being worked on right now. Currently, the standard is on an energy index. It's an energy use. It's a site energy use, essentially, currently. We are looking at carbon, and the carbon we are looking at would look at your fuel mix as well as time of day usage. So, yeah, in that case, when you have on-site power, electrification versus using gas on site, you're going to get different mixes, and then your mix of your power plant sources would probably come into play somewhat too. And I think we're going there. We're not there yet. I'm not sure we have exactly the right way to do it. We're going. It's a big lift, but I think there's some really good work that's going to go on, and over the next revision or two, we should be able to get there. Ashrae's got a task group on this too, and I'm not aware of what they're specifically looking at. So,
thank you.
I've got Craig Frieden. Is humidification required to comply with Ashrae 55? That can be problematic in cold climates. I'm not an expert on Ashrae 55. I believe there's a pretty wide humidity range that is included as being as in comfort. If you were to put the energy used to create to humidify, you might that would be included in the mechanical section of the ERI calculation. But I don't think we but I'm not sure whether Ashrae 55 actually requires any particular system to get to the humidity, and they have a pretty wide range of humidity that they consider comfortable. That's my impression, but I'm not an expert on that. Any other questions?
So for Ashrae, that your new standard here, it has to have a, if you're going to do, exceed the standard by 30%, which is a very common federal entity lingo. What is it using as a baseline? Like the 2007 one, I never did find much of a baseline in. Like 90.1 has Appendix G, and it says if you want to beat the standard, this is your baseline system.
So the baseline system, system is a rule set that is in ResNet 301, and it is basically IECC 2006. And so the numbers are designed to be 50% better or half of the IECC 2006. I think those numbers might get lowered in future revisions, but you know that was the initial ask, essentially. Which, when we started this in 2012, seemed like a really big place to go.
Building off of that baseline question that Mark had, fuel oil is pretty predominant in most of Alaska, especially when we're doing designs for residential. But traditionally, 90.1 is the basis, is a gas-fired appliance, and we can't do high efficiency with fuel oil. So is that addressed in 90.2?
So I'm on the building envelope side, so I'd have to take a look at that. But I'm gonna put my email, and I will check on it and answer if I don't know the answer for that. The intent was that we could be flexible and used in any system. So I suspect there is a way of doing fuel, the high efficiency fuel oil, but I don't want to say that for sure. I will check that out and get back to you. If you want to email me your email, I will put my
And the question is more is that we can't use high efficiency oil devices. They're just too much of a maintenance nightmare, and so we're stuck in the most efficient non-condensing we can get 87% efficient, and the heat is probably the majority of the energy usage in these facilities. So if the basis is a 92% efficient gas-fired appliance, we're pretty much messed up right out of the get-go. And understanding that that's going to have to be emailed on to the committee, but yes.
Yeah. So the way the ERI works is you can sort of trade off some mechanical equipment efficiency with some building envelope or lighting efficiencies too, because it's all in one calculation. But I would think that where you have that specific situation with your with fuel oil for heating and a large long heating season, you might want to look at how you would do that to get prescriptive requirements. You might have to up some of the building envelope requirements beyond where they are now, if you can't measure against that, because it's sort of, so when you have the performance pathway in IECC, there are limits. You can only trade off within the building envelope or within the mechanical. With the ERI, you can actually trade off amongst them. So you can probably, so I think you're a little bit more flexible with the ERI pathways in general, and there should be a better way of getting there without having to go to onerous levels of efficiency, if that makes sense to you.
Thank you.
How is window area integrated into the standard?
Window area is there is a minimum. There's a window area rule set, baseline, and then you can go more or less versus that. And then it's also based on obviously your SHGC and your U values for Windows. So there is. So you're all working off of the basic rule set, and I don't have the whole rule set in front of me.
Sure.
But yeah, your basic. And I can't remember the exact window percentage.
Okay. Thank you.
Does anyone else have any questions? I don't see any more questions on the chat box, Dr. Weston. So I'm assuming we are getting pretty close or past the 1 o'clock hour.
Yeah. So I do have. I did put my email in there. So if you have additional follow-up questions, I'd be happy to look them up for you. Or if you want me to follow up on specific issues with what the rule set says about this. Obviously, there's a little bit too much detail to be able to do in the presentation, but I'll be happy to follow up on that with you.